You see that giant grin on my face? Well, it's because in this picture, I am holding Mars in one hand and the moon in the other. I'm serious. This is a Martian meteorite and this is a lunar meteorite. Now, them being meteorites means they came to us, right? These are little bits of rock that hit Earth at some point in the past. Which of course begs the question, how do we know where they came from? They just look and feel like rocks. Well, the key is composition. We have been to the moon and brought rocks back. We know what lunar rock is made of. And while we haven't brought anything back from Mars, we have sent orbiters and rovers that have figured out the red planet's composition. And it's all a bit different from Earth. Here's some examples comparing terrestrial rocks, those are the black circles, to lunar meteorites in blue and Martian meteorites in red. The composition of these meteorites across a whole range of elements, not just the ones shown here, are too different from Earth's and too similar to the moon and Mars to come from any other place. But these are relatively rare. Most meteorites come from the asteroid belt. They're little bits of rocks from when the solar system was first forming. Which is another way we can tell Martian meteorites apart. They're a lot younger than those that come from the asteroid belt because there's been recent volcanic activity on Mars. Of course, we also have to ask how they got from Mars and the moon to us, and the answer is impacts. Something hit the surface of these objects and ejected material out quick enough that it never fell back down to the surface. We think most lunar meteorites left the moon within the past 100,000 years, but Martian meteorites could have been hanging out in the solar system for millions of years before they finally collided with Earth. Which makes it pretty neat to hold these things that went on such a journey to get to us.